All bits are created equal, but some bits are more equal than others. Here to discuss that point with me is Bob Frankston, who's just given a stimulating tutorial on the subject. Bob, could you just give us a short summary of what you described today?
Okay, I'm basically trying to explain that the internet is a very different concept from telecommunications. That it's really a byproduct of software, the ability to program. And the theme, if anything, in my talk is we can program around that. We can create our own solutions despite what happens in the middle. And Skype is a great example. That instead of relying on a phone company, people figured out how to create their own solutions. This was long before Microsoft bought them, when they could be even, they can be much more innovative because they didn't have to obey any rules.
So how did they achieve that when I guess the internet was in a fairly rudimentary form and packets were going everywhere, and some of the technologies for kind of recreating these with low latency and also with without distortion were not yet invented at that time?
Well, it's interesting because at the beginning they couldn't. You could think if in the 1970s we conducted this grand experiment. We created two different packet networks. One packet network was designed to carry voice. It's known as Signal System 7, and it's the basis for the standard telecommunications infrastructure, the PSTN, a public switch network. It worked very well, and the U.S., as the U.S. tends to do, thought we had the greatest phone system in the world. Of course, everybody else got at that point. But the thing is, it was expensive, but that was worth it to get clear phone calls around the world. The internet, you couldn't do that because it was basically good for maybe transferring files. You didn't have much capacity. Sometimes things didn't work. It was very unreliable. And because packets were sort of raw, you didn't know who owned them. You couldn't pay their way. There was no way to pay for better service. All you can do is pay for maybe fatter pipes, but those are expensive. Until Tim Berners-Lee created an application that people found useful, the web. That was a consumer application. So that just basically drove the adoption of consumer connectivity. And just as when you have anything to sell, if people are buying it, you make more of it. People buying a lot of it, the price goes down, because you can just get more and more quantity. In other words, it's not like some situation where we have a finite supply. It's more, we can add more capacity. We can use Moore's law to basically discover more capacity. And as the web drove capacity, it became more and more likely that the packets would get through. So enough packets got through by chance, an application like voice would start to work. Now, if you were paying, $5 a minute to speak to your family, say back in India, and somebody said, there's a 25% chance you'll get a clear conversation. For nothing, you'll take that chance. And what has happened over time, as the capacity increased, that went from a 25% chance to 99% chance, and you get video, but that's a byproduct. This is what makes it an economic issue, but an indirect one. We created the opportunity by funding a common infrastructure. It just happens to be that the web drove that, but then it was free to use for other purposes. The GPS is another example of a free-to-use resource that was created for another purpose.
So, am I right in saying that Skype was created at exactly the right time when the quality of service was perceived to be good enough because the capacity was at a sufficient level and that enough packets would be arriving at the right time to give a good enough quality of communication?
You can argue it was created just before it was supposed to be. That's when, like when we did VisiCalc on the Apple II, it was a little before things were taken seriously. So the timing was right, yes, but a lot of other efforts. So it's not as if, that they picked the right time. It's just the project and everything came together because the opportunity presented itself.
Right, so the stars aligned. There were many other companies before and after who didn't have the same combination of good conditions that would support their business.
Well, a good example, there were companies who were doing voice over Ethernet, which you can work locally. Skype just was able to venture out beyond the local network and create a VoIP service that worked. And there are commercial ones that came along, such as Vonage, which started to do voice over IP, but they made it look like phone calls.
Great. Now, a slight change of topic. Are some packets smarter than others? And should we pay more for those?
You see, the problem we have is we use anthropomorphic terminology that makes, so you use words like smart. Some piece of French toast smarter than others? We tend to basically also have physical metaphors. And a lot of this is the metaphors we use. So when you transmit a 0-1, you might have a signal wave that goes, but the zeros and ones are simply representations. So, we don't have to send, like if you want to send Wikipedia to somebody, you don't send Wikipedia, a copy of it, you send a URL. And they probably might have a local copy. They don't have to send it or go to the article they want. So the bits themselves are just a means. And you don't even know what those are. So when you look at a packet on the network, they're just zeros and ones. Another, actually better example is how many bits do you need to send a movie? Might be 1 trillion bits, or it might be 0 bits. You might have a copy cached locally. So that's why it's hard to measure the value of those bits on the wire, and it gets more and more decoupled from the ability to set a price on the bit. And you have to remember, a lot of this is accounting. So a phone company might invest in wire. How do they charge for the wire? It's a resource they use. They might assume so many calls, so much income per. But ultimately, we have to remember it's just a wire. And if we have a different policy model, we don't worry about bits. How much does a step cost on a sidewalk? It's meaningless.
So what would you say to companies or industries that want to charge us different amounts for sending different kinds of data down the same pipe, who want to control what it is we're sending down there?
Well, there are a couple of answers. Some of them are not suitable. But a more serious answer. I mean, there's one level at which I say, mind your own business, why are you reading my packets? But ultimately, if we assume encryption is something, they can't read the packets. So that isn't even an option for them. But the reason why they're used to doing that goes to history. In the days of the telegraph operator would have to understand the words you're using in order to spell them out. And if the operator receiving it would know English enough to correct errors, just like Siri does now, and probably the same kind of mistakes would occur. So traditionally, the business was adding value, and they would know it's a voice call would have value, if it's video to have certain value, and they're also used to selling services like cable TV companies. Some movies are more valuable than others. That's the old model where the carrier transported the meaning and the value is inside the network. The problem now is that, in the sense, they haven't got to the message that the value is now created outside the network. All they're getting are raw packets. They can't charge you for the meaning because they can't see it. What's confusing is that when people are sending text in the clear, you can see what site are we going to in this, so they can try to preserve the old business model in a desperate attempt to sort of deny that things have changed.
So what is the new model?
The new model is basically that the internet we create ourselves by what we did. So, it's like we own the sidewalks together. So I use the example of home networks. Originally, home networks were going to be a service like cable TV. With cable TV, you pay for each set-top box on a thing, or it's going to be like a phone line. So each PC was going to be like a phone call. Each internet connection was like, actually, I say modem, but people might not remember, but each internet connection had a separate, each PC had a separate connection. Just like with cell phones, if I've got this watch here, it needs its own account to communicate, and this phone needs another account. So that was the model for home networks. So what I did was I put the NAT there in the router. So now they couldn't. All they could see are raw packets.
So what did you put on the router?
Well, what I did was said, I'm going to share this connection with all the computers in the house. The way I achieved that was to put a network translator. Don't worry about a network translator. Just call it a router. And you own what's inside the house, and the phone company owns what's out, and they can't look inside your house to count how many devices you have. That's what changed the model. Now, we could extend that model for people in an apartment house to share the connection, a single pipe out. A city can do that and say it's like sidewalks. The whole city could own it. And then at the edge of the city, you might pay the railroad, which is very much like telecom, for a ride. But eventually, the model will be this is going to be free to use infrastructure like roads and sidewalks. And that's going to really enable innovation and also drive Moore's Law.
Well, that's a very exciting change in the paradigm. So, Bob Frankston, thank you very much for sharing that with us.
Okay, you're welcome.